All right, everybody, good stuff. My name is Josh Long. Welcome, welcome, welcome. Come on in, please. Have a seat. It's going to be fine, probably. I work on the Spring team. I'm a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And most importantly, I'm at your service. So should you have questions, comments, feedback, whatever, don't hesitate to find me on the inner tubes, on the internet. There's my YouTube channel. I have a YouTube channel. So if you've already tried the best, and now you want to try the rest, check out my YouTube channel. It's not terrible. Nobody, it's provably not the worst decision you could make today. So please find me there, youtube.com/@coffeesoftware. We're going to cover Spring Boot 3.0 today, okay? And so as a result, we're going to go through a lot of code. That code is here online on GitHub. If you want to follow along and play the home game, you're more than welcome to. Not now. Just take a screenshot of this slide, of my slide, and that'll be enough, okay? If you want to find out more about me, there's a link-free thing. There's a whole tree of links there. I'm on Twitter, and in case the Bird website burns down, I'm also on Mastodon. I'm on LinkedIn. I've got email. Anybody here using email? Email. Anybody? Email. No. Good. Moving on. I've got a podcast, and this podcast is it's not terrible. It's fine. It'll be okay. It's bootifulpodcast.fm. It's available wherever fine podcasts are streamed, and so on. So, my friends, today we have a unique and wonderful opportunity. We're going to talk about Spring Boot 3.0, which came out last year, November 24th last year, which was Thanksgiving Day. And normally, by the way, I never miss a podcast, but I missed it that day. You see, it was a Thursday, and I normally release a new episode of the podcast every Thursday. But it was Thanksgiving, which is a thing here in the States, and also it was Spring Boot 3.0 day, and I completely forgot. I just completely memory hold that I was supposed to get an episode out on that most momentous of days. And believe me, it would have been just me blathering on about Spring Boot 3 had I actually remembered to release it that day, but I forgot because I was so inundated with the joy of this new release. Spring Boot 3 came to us after a long, long march. It's got a lot of surface level features that you'll see in the next 45 minutes together, but there's also a huge mountain of things that support it, that are in the underpinnings of it. So we're going to cover those as well. I love Spring Boot 3.0. Okay, it's like Java. It just keeps getting way better every time, all the time. So I'm just really excited about this new release. But my friends, in order to look at all this stuff, we're going to do as we always do. We're going to write some code here on YouTube, on the internet. We're going to go to my second favorite place on the internet. Obviously, you know my first favorite place. My first favorite place is production, right? It's the happiest place on earth. It's better than Disneyland. And I was just in Disneyland. I still say that, right? I love production. You should love production. You should go in early and often as possible. But if you haven't been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application. I'm just going to accept the defaults, right? Groovy, Gradle. I'm going to use that. That's the new default, by the way, is Gradle these days. We used to use Maven. Gradle's fine. I had a New Year's resolution this year. I said I'm going to lose some weight and learn Gradle, and I'm definitely learning Gradle. It's going well. We have the new version of Spring Boot here, 3.05. I think that came out. It's a creakingly old version that came out last week, I think. We're going to call this Service, okay? I'm great with names. Really good. I'm like my dad. My dad, we had a little white poodle that showed up at our door, and so my dad named it White Dog. True story. Then that dog, 10 years later, mysteriously went up to a farm upstate in New York, and we lived in California. And then another white dog just turned up at the door, mysteriously, magically, out of nowhere. And there's another little white dog, so my dad named it 2. Now, I don't know if it was the numeral, 2 TWO or TOO. Either way, it works, right? And my mom suggests that given that, and given what we know about his proclivity for names, I am very lucky that he didn't name me, because you can only imagine what he would have called a little white baby. Anyway, I'm great with names, so I'm going to leave that as Service. I'm going to use H2. I'm going to bring in the actuator for observability. I'm going to use the web support. I'm going to use JDBC. I'm going to use, I want GraalVM support. Okay, I'm happy with my selections there. We also have the choice of what version of Java we'd like to use. Friends, the current long-term supported version of Java is Java 17. Okay, Java 17 is an amazing piece of software, and I'm going to use that because there's a current GraalVM release at that version as well. Java 17 is awesome. I love Java 17. It is technically superior to Java 8 in every conceivable way. It's also the baseline that's required to use Spring Framework 6 and therefore Spring Boot 3 on top of it. It is the new foundational layer. It is technically superior in every single way. It's faster, more robust, more performant, more secure, more syntax rich, more concise, more production worthy. It's also morally superior to Java 8 in every conceivable way. You won't like the look of sadness and despair and chagrin and frustration and embarrassment in your children's eyes when they find out that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17 at least. You should be on Java 20. You know we're less than 6 months away from Java 21? And you know what they just recently targeted for Java 21? Loom. Project Loom. In theory, if everything goes to plan, that'll be released in less than 6 months. GA. Come on, people, get on this. Get on this. Let's do the right thing here, okay? Moving on. I'm going to hit generate, and while that's generating, I'm going to open this up in my IDE. You don't have to use any particular IDE to work with Spring, obviously, but I'm going to use IntelliJ. It's fine, it's okay. And in the meantime, can we take a group photo? Yeah, okay. I want to take a little photo while that's opening up. Everybody pretend like you're happy, okay? Just pretend. Ready, steady, open source. Yeah, lame. Good stuff. Thank you. I want that. I'm going to put that photo on the refrigerator, and I'm going to show it to my daughter, and I'll say, see, they listen to me. Anyway, we're going to open this up. Here we go. New service. It's downloading the internet. That's neat. I am hoping that you're all not on the internet right now. That would be great. Let's see here. Ho, ho, ho. They released something new. Living on the edge. Well, do I need my database to talk to the database? It doesn't look like it's making all that much progress either, does it? Oh, look. Okay, very good. So what we're going to do, my friends, is we're going to build an application that talks to a database. Obviously, I'm going to start with the entity that we're going to use that we talk to the database with. Do I have enough power? Yeah, 46%, that's enough. We're going to build an entity. I'm going to build it using a Java record. Is this font legible in the back? Let me here, friends, I got an idea. Font size. Okay, let me see. Where's my font? Okay, I want this to be like current editor font 22, and then we want the theme to be light. Okay, hit apply. Yes. Is that better or worse? Worse? I hear a lot of worses. Should I go back to dark? Okay. I was trying to help. I'm just here to help. Okay, apply. You're awake. Who's stomping the floor? Okay, better? Okay, so we're gonna have an entity. We're gonna use records here, right? And I love Java 8 records. This is one of those nice features that comes in the newer versions of Java, right? So I'm gonna say, look, ma, no lambak. Isn't that nice? So nice. So I've got an entity, and I'm gonna create a service here, customer service. And this service is going to have a couple of methods here. One is going to be collection of customer, and I'm just going to return all. Wow, it is so awkward to type like this. I wonder if I can type like that. Let me see. That might be a little bit better. That is better. Yeah. So one is going to say return all. So we'll say I'm going to inject the private JDBC template here. This is a object that I'm going to use to talk to my SQL database. It's a object that's been in Spring for decades, and it works just fine. It's trivial enough that I can use it for this particular data access work. So I'll say this.template, okay, come on, template.query, select all from customer, okay? And that'll give us back the customer data, and I'm gonna now map that customer data using a row mapper like this, okay? And this row mapper is very simple. Given a result, I'll get the integer, so I'll get the ID, and I'll get the name, okay? So voila, name. Very good. So there's my basic simple row mapper. I can extract that into a lambda. It works just fine. You could even stash that as a variable, right? I could do like this, private final row mapper of customer, like that, and then store that, right? Works fine. So I can just use that, reuse that row mapper thusly. Okay, good. Not bad. And I want to do the same thing I want to have an endpoint here that I can use to find, or a method rather, that I can use to find records by their name, okay? So by name, string name. Return this.template.query, select all from customer where name equals question mark, passing in name and this .customer row mapper. Very good, okay? Easy. Now, we are, something is wrong. Something's quite wrong. Query for a list. I feel like that should have been enough. What did I do? I blame myself. Name. ChatGPT, where are you? There you go, good. So, this doesn't happen. I bet that never happens in ChatGPT. This is just a me problem. Okay, so I'm going to build a service, and I'm going to use the service in an HTTP endpoint, okay? So I'm going to create a customer HTTP controller, okay? And this HTTP controller is just going to be a, I'm not going to say REST endpoint, but it's going to be an HTTP endpoint that makes data available. And I'm going to, create some endpoints here. I'll say get mapping, okay? Customers all, and we'll say collection of customer all. And I'm just going to return. I'm just going to delegate to the service, really. I'm not doing anything particularly special here. So we'll say customers name like that, passing in the by name like that, and path variable string name path variable, okay? And here we'll say by name, passing that in thusly, okay? Very good. So we have two different endpoints. This is going to be an HTTP endpoint that has representations of state that are going to be represented by the JSON that gets returned from these objects or rendered by the controller by these return values. So good, there's our HTTP endpoint. Let's go ahead and start that up and see what we get. It's going to fail because we don't have SQL in the database. So I'm going to go ahead and create some schema here. I'll create a new file called schema.sql. Okay, I'm going to say create table customer, right? Customer ID, serial, primary key, name, varchar, 255, not null, okay? Very good. Now, what about the data? I want some data in there as well. Insert into customer. And we need some names. So anybody want to give me a name I can put in there? My name is Josh. It's so lovely to meet you. Who else wants to be my next volunteer? Volunteer. Who's next? Come on. Hans. Like H-A-N-S? Woohoo. Good. Next. Kimberly. Okay. Like this. Okay. Next. Adrian? Ryan. That's a good one. I don't hear that enough. Others? Adrian. Like that? Rock on. Okay. 6. Going for nice. What is it? Chandra. Like that one? Lowercase h. Very good. That's 6. That's a nice round number. That's fine. Let's go ahead and restart the application. I want to see the data when the application starts up. So what I'll do is I'll create a bean that listens for an event, right? Application listener. And I'm going to listen for the application ready event. And when the application ready event gets published, I'll respond to it by injecting the customer service there and then just enumerating all the data using that service. So service.all.forEach, well, I guess I could do that too. And then system out customer, right? Very good. So there's that. Return that. Fine. Restart. Take 3. Did that work? Yeah, there we are. It worked. Of course it worked. It was a demo. It was always going to work. There was no question about that. Now, moving on. Okay, here we go. We've got some data in the database. We've got our application. It's up and running. It's very good. Now, I want to build an application that's intended for production. And throughout all things with Spring, production is paramount, right? I care about production. So the first thing I'm going to want to do is to make my application just that much more robust. And so, for example, here, when I call by name, I want to make sure that I have a valid name and that the name starts with a capital letter. I think I did the right thing here. I think I had a bunch of names in the data.sql that were all starting with capital letters. Yes, it appears I did. So I want to make sure that when you request a name, that the name is as we expected, that it starts with a capital letter. So name.char@0, okay, character.is uppercase, this one. The name must start with a capital letter, okay? So I'm just going to assert the state of that thing. Now what's going to happen if that doesn't get met? Well, it's going to throw an exception, right? So if I look at this, it throws an illegal state exception. So let's go to the command line here, localhost, customers. Josh, that should give me the data, but let's go to the command line to use case and sensitivity. And I'll do lowercase j. Can you see that? J. Very good. So I got this JSON there, JQ. There you go. I've got this like error, and it's fine. The problem is that it's not particularly consistent if you have different technologies in play and different stacks and so on. So in Spring Framework 6 and Spring Boot 3, besides, we added support for problem detail. So you can say problem details enabled equals true. And this is an RFC, right? RFC problem details. Okay, here we go. And it's just a way to represent errors in a consistent way. It's just one of those nice little things that's been added to Spring. So I want to take advantage of that, but I also want to centralize my error handling. And one way to do that, very naturally, is to create a controller advice. So I'm going to say customer error handler, and it's just going to be a exception handler. And what did we say the exception was? It's going to be an illegal state exception, right? So I'll add that here. So whenever this is thrown from any controller in the stack, handle, I can inject the exception if I want here. Legal state exception, and in fact, you don't even need that anymore. And now I can return my own response for the error instead of handling the error handling in each controller method. So here, I'm going to create a problem detail. I'll say problem detail, new problem detail. Here we are, and whoops. Oh, problem detail, detail? I feel like I did my part. Where's this thing? Problem detail dot for, okay, there you go, for status. And we're going to say HTTP status code, what is the, we want HTTP status code, or just HTTP status dot whatever, bad request, okay? And I'm going to say PD set the details, and I can use the exception. I can say get the localized message, for example. I can do all sorts of things to customize this error, but I'm just going to do that, okay? I can also inject the current servlet request associated with the request. Maybe I want to debug that, right? And this is not particularly new. You probably knew about this. What is kind of interesting here is that this interface, this type, now lives in a different package, right? And that's not great. It's not great, because what that means is that every piece of code ever written against javux.servlet.http has now broken. It's a political thing, not a technical thing, right? And so we're all kind of just stuck with it. It's fine. It's going to be the worst find and replace of your life, but then you're going to be fine, right? It's easy to fix. I would be very surprised if there aren't tools you can use. I know Open Rewrite already has some solutions for that. And hopefully if you're using Spring MVC at the top levels, you're not even going to see this stuff, but it is there. Everything ever written against javux.asterisk, almost everything, is now going to break, right? Because it got all moved to the Jakarta, the Eclipse Foundation, and from a technical perspective, they did the best job anybody could do. They made it so easy for the community to slowly move to these new namespaces. They did a great job there, and we are all very lucky. And that's a big part of what's happened in Spring is we've worked with the community for the last several years to sort of move all these different projects to these different namespaces, to work with them, to make sure it worked as before, and so on. And they gave us 3 different releases that were basically the same, save for that namespace change. So we're in a good place. This is good for everybody, and we'll finally start seeing some things get addressed in the Jakarta specs that we care about, like the Servlet API and so on. So that's good, but you do need to know that that's now a baseline. There is no Java EE support. It's all Jakarta EE and so on in Spring now. Okay, another change. Now, what else do I want to do here? Well, let's just go ahead and run this and see what that gives us. Okay, we're going to go ahead and restart it. I have my error-inducing command there, and there you go. You can see when I make the request, I get a slightly different, representation of the error. I get the, instance and details and all that. It's fine. Good. So now I've got my controller endpoint, and I also want to observe. I want to know when something is happening, when somebody calls the endpoint. And so one way I can do this is to use the Spring Boot actuator and to capture metrics, right? Observability is a very important part of any production-worthy application. It's your ability to surface information about the application in such a way that you can see it in production, right? And you can respond to it, and you can do the right thing when something goes wrong. You can't know if you're winning if you don't know what losing looks like, right? Observability helps you understand one so you can appreciate the other. One way to get that observability, before is to support metrics, and that's supported by the Spring Boot actuator. Okay, now I'm going to add that to the class path. I've already got it to the class path. I'm going to expose all the endpoints, however. I'll restart the application. Here we go. Localhost 8080 actuator metrics, and that did not work at all. Let me see, web exposure. Did I not add this? Spring Boot starter actuator. I think I did my part. I feel like I did. So what did metrics. Sorry? Metrics. Wait. There you go, metrics. Well, it's not great. What did I do? So show details, always, probes, enable true, build. I have a what? Oh. Oh, thank you. I would have been here all night. Again, ChatGPT would not have had this problem. Okay, actuator / metrics. There we are. Good stuff, right? There's all these different metrics and points. These are statistics, things like the mean, the median, the average, etc. All these things that tell you interesting information about the application itself. So here's my HTTP requests. Look at that, HTTP server requests. You go here, you go to there, voila. You get the details about how many requests were made. Now, this is one side of the observability coin. Another side is distributed tracing. You use metrics to tell you in aggregate what the trends are, what the patterns are, what the shape of your data looks like. But if you want to double click on the details, if you want to see the details, then you need distributed tracing. Distributed tracing allows you to see the flow of a request in the system from one hop to another. And historically, traditionally, before Spring Boot 3.0, that was a little bit of an asymmetrical story, right? So before, you have Micrometer, right? Micrometer is the project that powers the metric support here. Micrometer is vendor neutral application observability, okay? And this is a project that we built prior to Spring Boot 2. You don't need Spring to use Micrometer, but Spring does require Micrometer to do its support there. We built this to just handle capturing and emitting metrics and publishing those metrics to your time series database of choice, including but not limited to AppOptics, Azure Monitor, CloudWatch, New Relic, OpenTelemetry, Wavefront, Google Cloud Stack Driver, StatsD, Ganglia, Graphite, etc., etc., etc. So we had Micrometer, and then we have Spring Framework, which sits on top of that, and we have Spring Boot, which sits on top of that, and we have Spring Cloud, which sits on top of that, and then we had Spring Cloud Sleuth for distributed tracing, okay? So you had tracing, and then you have metrics down here, and there's a bit of an asymmetry there, because this meant that if you're writing code in Spring Boot land, you can't depend on Spring Cloud Sleuth, because that would create a circular dependency. So in Spring Boot 3, we have fixed that situation. This is gone, and now tracing and metrics are both supported by this new unified observability abstraction called Micrometer. So now we can take advantage of that and a new API to boot to make this code just that much more robust. So let's instrument this. We're going to use a new observation API, create not started. We're going to call this by name. Well, you can call it whatever you want, but you know. And for it to work, you're going to need a reference, a pointer to the observation registry. Okay, registry. Voila. Add that to the constructor. Oh, don't make me do the work. I'm allergic. Look at that. What is going on? Read my mind. Oh, so much extra. Okay, so here we go. This dot registry, okay? And then I'm going to create a wrap. Is that it? No, observe. There you go. Supplier. And my supplier is just going to produce a value, right? And the value in this case is going to be the collection of records. So I'll say, here, collection of customer, voila. And, you know, it's a suppliers, and it can be a lambda, of course. Implement that, and I'll say return service dot all, okay? So now, let's clean this up, please, like so. Okay, better. And I no longer need this, and this can go up here. Okay, much cleaner. So now what I'm doing is I'm using this new unified API. I'm creating a scope during which, or inside of which, things are observed. So if I were to start doing tracing, or if I were to make a call to another service using, for example, the Spring Web REST template or the web client or whatever to another endpoint, that would automatically propagate trace headers, which would then be used to, you could then emit that out of band to things like Zipkin and OpenTelemetry and whatever. It's also creating this metric, and here's the key, and it's going to keep account of that based on how many requests we get. Okay. Now, it doesn't automatically capture all trace information, so you want to make sure that your probability is equal to 1.0. Otherwise, it'll capture a subset, a random sampling of all the requests, because you don't want to overload your tracing system with every single request going through the system, right? You'd have to deploy 2 productions, basically. So we go here, customers, by name Josh, refresh, 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 refresh. Go to actuator, metrics, and then we can see by name.active. Right? Go there, paste that in. Voila, there we go. I made 18 requests in, you know, however long it took me to do that. Here's how many requests we got, the total time, et cetera, et cetera, et cetera. Now, all of this is hopefully invisible to you. And by the by, for those of you who are wondering, yes, you can use the annotation. So I don't have to use this. You can just do @timed You don't have to use the observation API. You can use @timed to wrap the method invocation in an observation scope, if you will. Okay, now we have this new unified observation API in Spring Boot 3. It's really, really powerful. Again, you can now have the same API to talk to your distributed tracing system and your metrics time series database. I won't go into the details here. Jonathan Ivanoff from the Spring and Micrometer team has done a talk or will do a talk. It was awesome or it will be awesome. I don't know. Either way, just watch it. If you're watching this on YouTube in like 2 days, it was awesome, statistically. Okay, good. All right. So we've got our application. I think we're ready to start thinking about getting this thing to production. Friends, the first thing that comes to mind when we get things to production is how do we package this, right, for production? Today, production as often as not is some sort of container orchestrator like Kubernetes, right? And so the first thing I'm going to want is how do I take this and turn it into a Docker or OCI image? The easiest way to do that is to use build packs, right? Build packs are a cloud-native computing foundation specification that allow you to take your application artifact, be it a Java application or a Node.js application or Ruby on Rails application or .NET assembly application or a Python application or a I can't say it, it's not a language or refuse. Anyway, you can use that one too. You can use build packs to automatically turn any artifact into a container. So application source code in, container on the other side out. And there's a number of standard like recipes that you can use to turn your applications into these containers. Very simple. Remember, friends don't let friends write Docker files. Don't do it. There are better ways to solve your time. Nobody's going to come to you late on a Friday night and put their hands on your shoulder and say, great job, way to write the best Docker file. It's a waste of your life and time. Go home. Use build packs. Seriously, what the hey? You're not going to do a good job, and worse, it's going to become out of date as soon as you forget about it, right? Instead, use build packs. You get a standard, consistent, memorized, industry practice, best practice worthy recipe for packaging applications. Who knows how to deploy production worthy Spring Boot applications better than the Spring team that built the recipe for doing it, right? Trust us. If not on this, then on what, So use build packs. You can use the command line CLI, it's fine. Or if you like, you can use the Gradle and Maven plugin integration. So Gradle, build boot image, and Maven Spring Boot :build image, okay? You can use that, that's fine. I won't show you that. What I want to focus on, because that's not a particularly new feature, it's just one of the things that comes top of mind when I think about production-worthy Spring Boot applications. The next thing I care about is making my application as efficient as possible. I want it to be fast and efficient. And here, friends, it's worth taking a moment back to highlight, to emphasize, to stress that Java is really, really fast, right? This is, whoops, wrong one. This one, here, we'll come back to that one. Which programming language uses the least electricity? This is a great report from the new stack from a few years ago where they looked at languages normalize global results for energy, time, and memory, right? And they actually look at the relative performances of all languages where C is the baseline of a score of 1.0. Rust does particularly well, C++, Ada, which I'm happy to forget, and then Java, right? Well, no, I mean, it's not that Ada's bad. I'm just saying are you using it? Am I wrong? Is there like, okay, we're okay. We're gonna ignore that. It's nothing wrong, and it's just not here anymore, So what I'm saying is, for all the languages on the list, Java's like twice as inefficient, or C is twice as efficient as Java, right? But not bad, really good. And this is like 2018. It's a nice table. Compare that to other languages like JavaScript, which is certainly prolific and serves people well. It's much worse. You've got like Python, which is everywhere. 35 times worse. I mean, Java's fine. We're doing okay. It's a good, fast, efficient way to write software and deploy it to production. Don't let anybody tell you otherwise. And there are a couple reasons it's so efficient. One is because of the garbage collector, right? The Java garbage collector is a miracle of modern software, which brings me back around to my friend, the original Java garbage collector, who has a claim to that. Her name is Jesslyn. She's from the island of Java, Indonesia, and she is a Java garbage collector. So, yeah, exactly. And I love this tweet because look, there's like 20,000 likes basically. What that means is that there's an intersection of people that appreciate Jakarta, and Indonesian and Java geography jokes, and Java, the programming language, and that's all of them. We found the entire Venn diagram right there on that tweet. Good stuff. We live in an interesting world. So she's got the first claim to like the OG Java garbage collector, but the one we have in our language is fine as well. It's awesome, right? It works great. That wasn't the way it was, not like that. Like, it's great, works well. So, part one, okay? Now, the other thing that makes Java so amazing, is the just-in-time compiler. The just-in-time compiler does an amazing job at taking your code and turning it into a native bit of code, native optimized machine and architecture-specific code, okay? Now, this code is fast, and it's one of the reasons why you can take a production application, exercise it, get some bandwidth, get some traffic going to it, and then see it perform much better than it would have otherwise, right? Large organizations like Alibaba and Google take advantage of this dynamic. They actually deploy software to production, warm it up, and then see the result actually, get faster than they deploy that to production. They turn on production traffic. Awesome, right? The just-in-time compiler works by taking the code that it can find and can be very sure about and excluding the fun in your code, right? Any place where you're having fun, it won't work. So what I mean by fun, all the things that make Java so dynamic, things like reflection, proxies, serialization, any of the fun things you can do in Java, the language. Remember, Java has a runtime. This runtime makes Java one of the most dynamic languages out there. For all of its stodginess and the syntax words and whatever, it has a lot more in common with the likes of Lua and Ruby and Python and whatever than it does the likes of C and C++, right? It's a very dynamic language. You can, in a roundabout way, take a Java lang string which has syntax source code and turn that into a class file that gets written to the file system that you then load in the class loader, which then gets reflectively instantiated. And then, you can do that all at runtime without ever having a concrete type, right? You can do eval, basically, in a matter of fact. So all that fun that you might do in Java, you can't do it in the code that gets optimized by the just-in-time compiler, okay? But it does a pretty good job for those code paths where you're not having fun. The question then is, if it's so powerful, why don't we proactively just turn the whole application into native optimized code? Yeah, it's a great idea, except you do need to account for all those places where you're having fun, right? So, and remember, this mechanism, this idea of ahead-of-time compilation, it's not compatible with fun, right? So there's a way to do it. It's called GraalVM, and GraalVM hates fun. But it gives us a way to solve this problem. It gives you a mechanism that you can use to account for all the places where you're having fun in your code, okay? And this mechanism is JSON config files. You got to plug in these JSON config files into your GraalVM image, into your compiler, and you tell it, hey, I'm going to do reflection on this type, make it work. I'm going to create a serialization. I'm going to do serialization. I'm going to create a proxy for these types, make it work. Okay, good, easy. But there's a lot of that. So who better to? You could do it, but it's a lot of work, right? I don't want to do all that work. So Spring is a naturally good place to do it for you, right? Because we're the framework. We see most of what's happening there, and indeed most of the things that would need to have that dynamic behavior comes from Spring itself. So Spring does that in Spring Boot 3. This is a new feature in Spring Boot 3, is that we have an AOT engine, a ahead-of-time engine, that does all this accounting for you, okay? So what I'm going to do is I'm going to kick that off here in the background, okay, service. I'm going to say Gradle, native compile, okay? And here we go, ready, run. Now this is going to take a while. That's the only problem with this. It takes a long time, in fact, and it's kind of annoying, and I finally understand this slide, okay? The #1 programmer excuse for legitimately slacking off. I didn't understand this joke when this first came out years ago. I'm there now, okay? I get it. It takes a long time. These GraalVM native image compilations take a long time, but they take not enough time that I can do something else, but long enough that I get kicked out of the flow, right? Which is a problem, because it's just agony. I'm just sitting there like, looking at the ceiling or something. You're supposed to like take every hour or something like that, you're supposed to look at a corner far away and look at something close to keep your eyes healthier, right? I do that now because I have reasons, right? Like there's time. So I finally understand this, and the problem is I hear elevator music when I do these long-running compilations, and I just hear it in my head. I don't even have to listen to something. I just hear something, elevator music, and I thought, well, great. Wouldn't it be great if we all could hear the elevator music? So I went to the official Oracle GraalVM project, and I filed an issue, and I said, would you please play elevator music during the native image compilation process? And I said, look, I already hear elevator music in my head while I do these sometimes long-running compilations. I just like everybody else to hear it, too. And then I said, thank you in advance, and I appreciate your amazing work, which is true. I do. They're doing us all a big favor, and they give it away. It's amazing. So our friends from Red Hat came in with this, can you please make it this elevator music? I don't want to play the video. It's the soundtrack from the GoldenEye. You remember that James Bond movie, GoldenEye? There's a video game, and they actually had elevator music in one of the tracks. It's awesome. So I was like, okay, well, that would be great. I was happy with that. And then somebody else said, hey, well, I would add that using beeps in general, not only for the native image, really helped me reduce development time. Yeah, beeps would be great, like an asynchronous callback. Just notify me when it's done so I can come back to focus. And then Fabio Niephaus, this is him. He says he's a researcher on the Gravium team at Oracle Labs. He is also a doctor, previously at Google Colab and Matan Guitars. Forgive me if I'm butchering anything in pronunciation. And he wrote this very thoughtful, caring message. He says, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making Gravium native images more efficient in terms of time, memory, and CPU consumption. Anyway, he continues, I have prototyped a -- Josh Long mode. But for some reason, I have the feeling my PR will reject it all. Probably because of the copyrighted music. On a more serious note, yes, we could add a --ring bell when done option that prints the bell code after the compilation process. Here's what that Josh Long mode would have looked like. Oh, the possibilities. So you would have done native image, Josh Long mode, right? And then it would have said, music brought to you by Josh Long. And then me, right? And I think we're missing, that could have been the future that we could be living in, right? But we're not, and it makes me sad. So anyway, yeah, it's probably done building now. So let's go here. We're going to go to the build directory, native compile, and we're going to call service, and we'll just kick that off, and it's going to fail utterly because it's still running over here. Okay, take two. There we go. So there's my application. It started up in 0.08 seconds. What is that? So 0.1 seconds would be 100 milliseconds. This is 80 milliseconds. That's less than 1/10 of a second. It's just really, 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 really fast, right? But who cares about the speed? I don't, right? Unless you're doing serverless, in which case this is great for you. What I care about is the memory footprint, right? And so the memory footprint here is, oh, so good. Check this out. Where's my process identifier? Here we are. So I'm going to get that PS-O RSS, and that gives me if you do some scaling, you'll see it's 100 megs or so of RAM. How much RAM does your application take? A slack worth? More like 2 slacks or 1 slack? Yeah, right? It's a lot of memory, right? Java application. And by the way, you can see the years have not been kind to me. In 2004, I went into a data center in the freezing cold with my jacket, and we used to go into these buildings where they had computers and it was freezing. So I went in there and I plugged in patch cables into all these different servers in our rack. And I was just like, I wonder how much RAM these things are taking. This is 2004, before 64-bit computer operating systems and JVMs were prolific, right? So we had 32-bit, and all those applications in 2004, 19 plus odd years ago, were running with 2 gigs of RAM. And we wanted more. And then actually, a few years after that, they would have this whole wave of all these different versions of Java, all these different technologies that were doing off-heap RAM, right? Like distributed data grids, for example, right? And it was a big thing. We wanted to be able to address terabytes of data of RAM. And Java just has a garbage collector, which was very slow for anything more than 2 gigs. So that was roughly where it landed. It stopped at 2 gigs. If you had told me 20 odd years ago that I'd be standing here before you today telling you we can do as much as we did before in 100 megs of RAM, I don't think I'd have believed you, right? We're in a good place. This is cool. Now, this is not going to be, it's not a perfect solution, okay? I'm not saying it's going to be perfect. There are going to be some issues. If you do something fun, you need to account for that. By the way, did you all see this? A moment of he was a legend. Have you ever used JSR 330? Bob Lee passed away. He was stabbed in San Francisco. JSR 330, if you ever used javax.inject or jakarta.inject, he created that, right? He's a huge, instrumental human being in the Java community. worked on the first versions of the core libraries for Android. He created Juice, the dependency injection framework. He worked with Rod Johnson to create JSR 330, and he got stabbed last night, or yesterday. Yeah, so he was the CTO of Square, a big company. I mean, he's amazing, and anyway, the world is worse for his passing. Anyway, yeah, that's sad. I don't mean to bum everybody out. It's just he deserves a moment. Okay, so anyway, if you want to learn more about the GraalVM support, I have a few options here for your friends. There's this video I did a couple, 6 months ago. It's called Spring Tips, The Road to Spring Boot 3 Ahead of Time Compilation with GraalVM. It's 2 hours. It's a slog. It's like 66% of the last Batman movie, right? You really need to or 66% of the last Avatar, right? You really need to earn it. But if you do, there's a lot of stuff there, okay? And hopefully that'll help. If you're not into the moving pixel picture thing, I wrote a free ebook that you can get here called Everything You Never Wanted to Know About Spring Boot 3 AOT. It's like 50 pages. It's a quick read on the toilet even, it's easy. So get that, you can download it. It's like you have to sign up, right? It's free as in cost, okay? But otherwise it's there for you. Hopefully either one of those will help. Okay, so we've got our native application, we've got our code. Let's talk about building a client. Okay, so what I want to do is I'm going to go here, start.spring.io, and we're going to build a client. And we're going to go back and again, I'm great with names, so I'm going to call this client, okay? And I'm going to use the reactive web support. I'm going to bring in the Spring Cloud Gateway. I'm going to use the GraphQL support, and of course, I'll bring in the GraalVM support as well. And we're just going to build this client here. I'm going to hit generate, and I'll open this up on the command line, downloads. Oops. Okay, sorry. Here we are, UAO client.zip. And the goal here is to have a thing that talks to our service. The most obvious and natural thing we could do to build a client is just to actually build a client, to build something that is going to use an HTTP client to talk to our HTTP service. Okay, so let's take a look at that client. Can you all see that still? Okay, so I could do this. I could say customer HTTP client, and I could create an endpoint here that returns a publisher, a reactive stream of customers. By the way, I'm going to do something terrible here in the interest of expedience, something that you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. I'm going to copy and paste some code. So I'll take that. Here we go. And we're going to say, I could do this. I could actually implement that, but that sounds suspiciously like work, and I don't like work. So what I'm going to do is instead, I'll use a new feature in Spring Framework 6 and Spring Boot 3 to create a declarative interface-based client for HTTP. So I'm going to call this, customer HTTP client. I am going to use the client-side mapping annotation, not the server-side. So you can see I've got get mapping for server-side endpoints and get exchange for this, okay? So I'm going to take all that, by name, path variable, that's shared between client and server, so you can use both there. Okay, there, that's my interface. And what I want to do is I want to define that bean. And this requires a little bit of work that if I'm honest, I think should be a little simpler, but it's not all that bad, and especially considering the alternative, which is writing the code yourself, which, who's got time for that? Webclient.builder, okay, I'm going to say builder.base URL, and the base URL is HTTP localhost 8080, okay, .build, and I'm going to create an HTTP service proxy factory, okay, .builder, what am I doing? Builder, client adapter, pass this thing right in there, and then say .build, and then get the client for the customer HTTP client.class. Rolls right off the tongue, really easy, look at that. Okay, so anyway, that's fine. All I'm doing is I'm using this to create an interface-based definition, for me, and I can inject that anywhere in my code like I would any other bean. So I can say application listener, application ready event, here we go, turn, new application listener, good. Okay. And we're going to use the customer client there, and I'll just say client.all.subscribe, and here I'm just going to print out the results. Okay, very good. And this can be a lambda, just as before. And I need to make sure this application starts up on the right port, so I'll say port equals 9999. We'll restart that and let's see what we get. Okay, first client. There we go. It's started. What happened? There you go. There was the data, okay? So it worked. Great. We have a declarative client. We're able to easily build a client for our service without actually writing all that much networking code. Good stuff. There's similar support for RSocket, which is a reactive binary protocol. Awesome. And we're going to, conceptually, we could do the same for GraphQL and other things as well. You might know that there are similar alternatives to this in the Spring ecosystem. Spring Cloud Square Retrofit, Spring Cloud OpenFane, and even a little project I created for RSocket called Spring RetroSocket, all of which are, they're superseded basically by this. So check this out instead. And this is in Spring Framework itself, so it's available to everybody, not just in the Spring Cloud tier. Good, so I've got my declarative client. That's one way to connect clients to the downstream data, is just to build this interface-based client. Another is to use a gateway. So I can say, customer gateway configuration, and I'll create a bean of type route locator. And this is not a particularly new feature, it's just really awesome. I like to show it to people. It's using Spring Cloud Gateway. How do you use Spring Cloud Gateway? Don't all raise your hand at once now. Oh, goodness, it's an API gateway. It's awesome. Look at this. I can just create a route, rs.path, proxy. So when the request comes in, I'm going to match the incoming request on localhost port 9999 /proxy, and I'm going to send it to localhost 8080. But the thing is, I want to change the path. I want it to go to /customers, but I've got a path of proxy, so I'll use filters. And this is the real magic of Spring Cloud Gateway, is I can change the path here. I can say set path customers. I can also add, there's a bunch of other filters that you can use here. Set path, retry, redirect, add response headers. I can do all sorts of stuff there, okay? Yeah, good stuff, okay? Now, let's go ahead and restart that, see what happens. Come on, faster. People are waiting. Localhost 9999. Proxy, we said, right? There you go. So I go to proxy, and I get the JSON from my localhost 8080, right? And I can do things like add custom headers. I set the path here, but what you might do is add response headers, for example. So now I can interpose things like security, things like access control, access control, allow origin, asterisk, etc. And if I go to the command line, curl http localhost 9999 /proxy -v, and you can see that I got the content type application JSON, I got access control allow origin, which isn't in the source endpoint, okay? So that's another way to connect your clients to your services. One way that I quite like is to use GraphQL. Now, Meta, Facebook at the time, had a very interesting problem back in 2012. They wanted to make it so that their clients got all the data that they needed and no more as quickly as possible. Whereas the natural trend, the sort of trend for things these days has been to move data into different services, into different ports and hosts, and to make it hard for clients to get all that data. So you ended up building an aggregator service or a client that would then pull that data and get you a client-specific view of the data, right? And this gets tedious because whenever an iPhone client or an Android client needs a new view of the data, you have to bother somebody to update the code for the adapter layer, and then that gets sent back to the client. And it's just slow going, and it's just not very efficient. So, GraphQL. GraphQL gives you a way to describe your types and to seamlessly weave them together. And you start by building a schema file. So you say resources, source main resources, GraphQL, schema.graphqls. It could be called whatever. You describe the types in your system. I've got a type called customer. It's got an ID, okay? And I want to describe a field that people can read to get all the customer data. Well, okay, so I hang that off of, by convention, a well-known type called query, okay? And I'm going to create a field called customers that returns an array, that's what these brackets are, of customers. I can also do customers by name string customer, okay? And now I want to implement that query field, okay? I can do that easily. I can say add controller, same controller as before, for RSocket, for HTTP, for REST, for views, whatever. So customers GraphQL controller. Okay, I can say query mapping and publisher of customers. I'm going to just inject that client that we just built, so painstakingly. Customer HTTP client. Add that to the constructor. This dot customer HTTP client.all. Very good, okay? So there's that GraphQL thing, and I'm just mapping this controller handler method called customers to the field called customers, okay? What about the one with a parameter, okay? Query mapping, publisher, customer, customer's name, okay? And this is an argument, right? Spring data, a Spring for GraphQL argument, name, return this.client. I don't have an actual endpoint for that one, so we'll just skip that actually, but here you go. Okay, so we restart this. Oh, we need to be able to interact with that GraphQL data. So I'm going to create a client here, graphical. I'm going to use the graphical client. I'm going to stand it up as an endpoint that's available in the application. Just use that property. You have to set it to true. Okay, localhost 9999 graphical. Okay, very good. So if I go here, query, customers, notice I get auto completion. I get this like nice control space ability. It tells me what types I've got. You know how much work we do to make it so that HTTP and REST and all that has schema? You know, we had to graph that on. It's not a thing that's just there by default. It's because that wasn't really built for like service-to-service communication, right? REST is a constraint. You know that book, JavaScript, The Good Parts? REST is like HTTP, The Good Parts, right? It's a subset of all of HTTP, and it's what you use to build services. But it's just not, it wasn't built with like homogeneous service-to-service communication as you might find when doing microservices. So this is really convenient. You just hit control space. You've got all this stuff here. I can also easily add new things to the graph. So for example, let's say I wanted to add a new type called a profile, okay? And the profile had an ID like this, and I want this to be available whenever somebody gets the customer data. So this doesn't exist in my existing microservice, right? I don't have an endpoint there. I don't have any relationship in the data for the profile there, but I'm going to add it now. So now I've got a profile type, and I'm saying that this customer now has a field of profile that isn't present in the source data that we're returning. But I can weave this view of the data seamlessly without the client being aware of how it's being done. So here, I'm going to use schema mapping, and the type will be for customer, and I'm going to return a profile given the aggregate root type, the customer here. Okay, so return new profile, customer.id. Okay, let's restart that. So query mapping is actually a specialization of schema mapping that defaults to type name equals query, right? It's a meta annotation, just like you've seen before countless times. Okay, so reload this, refresh, great, no big deal. I don't get the profile data unless I want it, in which case I get it, right? So I can easily add this new type, and I can ask for as little or as much of the object graph as I want. Now here I just inlined the object, but imagine talking to a database to get the results. You can see how that would work. And of course here, n+1, that's not great, right? This is nasty. I don't want to call the profile service 10 different times if I have 10 different customers. So instead, GraphQL gives you another optimization where we can do batch mapping. And here, what you're doing is you're saying, I have a map of customers to profiles, okay? So in this case, you get a list of customers. So given a list of customers, return a map that contains all the data there. So var map equals new hash map of customer to profile for var l customer map dot put l new profile l dot id return map. Okay. So now imagine you have like a SQL query where you can do like select all from customers where select all from profiles where customer ID equals whatever, or in whatever, right? You get a range. So now I can do just 2 calls to get all results. Same exact response from the client's perspective though. Nothing changes. So I can easily weave together this graph of my objects. Good stuff, good stuff. So hopefully, by the way, all that works as a GraalVM native image as well. We don't have enough time, so I'm not gonna run it, but the code's online, you can try it for yourself. Who learned something new? Good stuff, right on, rock on. Who had fun? Oh, good, I'm so glad. Please vote accordingly or they won't let me back. Please. Hey, look, if you didn't get what you're trying to get out of this session, you want to learn more, there's a great free resource that we've got called Spring Academy. There's an upsell, but there's a lot of free content that's just there. It's designed to make it so people can get on the road to certification with Spring. Please try that out if you like. A lot of people have been trying it out since we released it earlier this year, I think. It's just spring.academy. Check that out. And of course, spring.io guides. Also very, very focused, easy introduction to all things Spring. Friends, what did they tell me? Thank you. Oh, so good to have friends that remember things. Okay, wait. Oh, I lost the There's something important. Okay, so please stay for the conference reception starting right after this presentation is finished. I guess that's now. There will be food and drinks. There is team tech trivia with prizes. We also have board games at the end and cake at the Jakarta booth. Good stuff. I'll take questions now, but otherwise, thank you so much, Devnexus. I appreciate you.